Matplotlib is a plotting library, and to import this library, commonly we do import matplotlib.pyplot as plt, and to generate data and work with arrays we need numpy, so we will import numpy as well. And when working with Matplotlib, it is often helpful to add this line into your code that will enable displaying plots in line, that is displaying plots within your output. I don't find this always necessary, but sometimes when you run your Matplotlib code for the first time, it doesn't generate the plots, so it's helpful to include it in your code. As a first plotting example, let's generate our x and y data. So for x, I'm going to generate numbers between 0 and 3 pi at the steps of 0.1, and our output will be np.sign, the sign of our input. So we have our data here. I can print this by print x. Let's say we want to look at the first 10 numbers, and we also want to look at y first 10 numbers. So this is our input list at a step size of 0.1, and here's our output of the sign function. So plotting this input-output pair is very straightforward in Matplotlib. If you remember, we imported pyplot as plt. So I can do plt.plot xy, and it plots the input-output. Here's our x, and here's our y. And oftentimes, after doing a plot, it is helpful to include or write this statement plt.show, so that you don't accidentally plot additional things into this plot. In other words, this show function, show method, closes your plotting so that you don't add anything further to your plot. And with just a little bit of extra work, that is, if you don't close the plot right away and add other things to the plot, you can easily plot multiple lines at once, and add things like title, legend, axis levels, and so on. So here's our first output, y sign. Here's our second output, y cos. Now we have three variables, x, y sign, and y cos. And first we will plot x versus y sign, then we will plot x versus y cos. So we have two plots that we can expect now. We are setting the label of x-axis as x-axis label, y-axis label, and the title is sine and cosine, and we will also have legend as sine and cosine. And if we run this, we will see that we can easily draw multiple plots, multiple curves in the same plot. Also, sometimes it is convenient to plot multiple plots at the same place, even though you can manually generate separate plots. If you need to plot multiple things at the same place, or if you're automatically generating data and plotting, it becomes cumbersome to combine various plots. So it is very common to draw multiple plots in the same plot, known as subplotting. And this can be achieved using the Matplotlib's subplot function. Here's how we do it. So similar to our example before, we have x and two output variables, y and y cos. So these are three vectors that we have. So to plot the first subplot within our big plot, we can use the subplot method. And what this does is, in a way, assigns or sort of points to the grid within your overall plotting grid where Matplotlib should plot next. In other words, now I'm saying make a grid of size height equals 2 and width equals 1. So now I can plot two things here, two subplots within this plot. And within this grid, in the first place of this grid, now plot whatever I type. So now I'm saying plot x and y sign and give it a title of sign. So that means that in this grid of 2, 1, in the first place, plot this curve. Now in the same grid, 2, 1, now in the second place of this grid, plot x and y cos. So the first place of this grid will be occupied by our sine plot, and the second one with the cosine plot. And then finally, I close the plot by plt.show. So here's our first plot, second plot. If I change the grid to 2, 1, so I have it in a different way. 2, 1, and then this becomes 1, 2. Then you can see that we have organized the grid in a different way so that sine and cos, those two plots appear in a different way. What's very, very important when working with subplots is to make sure that your every subplot line has the same expression in the first two parameters. The first two arguments should be exactly same, because otherwise it'll throw errors. So we will use Matplotlib and this plotting technique very frequently to plot the relationship between input-output variables and to see if two variables are correlated or not, and so on. Sometimes what we would like to do is see the relationship between three variables, and Matplotlib doesn't easily allow you to do that, and Plotly, another library, allows you to do that very easily. Google Colab doesn't always come with Plotly installed, so to install Plotly, all you have to do is since we're running Python 3, we actually need to do pipe 3. Pipe is for Python 2, so I can do pipe 3, install Plotly, and it says requirement already satisfied, so I probably didn't even need to install it. So let's load a data set, a popular data set known as iris, and so this data set has a lot of columns: sepal length, sepal width, petal length, petal width, spaces, and spaces ID. Let's try to see the relationship between three variables. Let's say sepal length, sepal width, and petal width. So to plot the relationship between these three variables in Plotly, it's pretty easy. We simply import Plotly by doing import plotly.express as px. Now we have px as our imported library, and then I simply do plot px.scatter3d, provide the data set, and I specify what is the x in my data, what is the y in my plot, and what is the z in my plot. And I can also specify use a fourth column, say for example spaces, to color the scatter plots in various colors. So let me run this, and what we get from here is a 3D plot. As you can see, what we have is a 3D plot. Essentially, this is effectively, actually, we're checking 4 dimensions because we're looking at 3 variables and the color represents the 4th dimension. So we can see that the spaces, or the 4th variable, is pretty much very separated by petal width. So smaller petal width corresponds to one particular class. In between there's other, and higher values correspond to another class. Similarly, this variable sepal width, we can see that it also sort of relates to the 3 classes, but not as much as petal width. And then we can also see how much sepal length. Now this plot is not always as easy. We can see that sepal length also has a similar relationship. So this is how we can sort of visually compare the relationship between 3 variables and the 4th variable as a color as well, using Plotly.